Okay, gang, we are gonna do some practice problems that look kind of scary, but no worries. Some tips as I draw this out is that as you do the problems, don't freak out because you know what you're doing. And the hardest part about doing the problems is making sure that the mechanism is correct. Because if your mechanism is wrong, then that means that you are likely wrong. So as we start doing addition problems, they're scary, but they're only scary because they're new. So you know what you're doing, no worries. When I look at this problem, I'm like, okay, I need to find A, B, and C. I know that my A and B will create the same C, which is nice, and that my C product will create this. So I'm thinking, what is going to happen in order for me to create one, the same product, but also a product that will create this? So you can go backwards or forwards. I just kind of do a mixture of both. I know that my starting product will have 9 carbons and a bromine, and my end product, count the carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, which makes sense. We don't get rid of carbons when we do these problems. We only form double bonds and break double bonds. So I know that I have to have a double bond somewhere here in this part, because going from C to, pretend this is D, in order for this mechanism to happen, I have to have an alkene, pretend this is my alkene, plus a metal, which is this PD. It's got hydrogens on it, and then these carbons are going to come over and take these hydrogens so that I get this, which is the same thing as this, because these hydrogens aren't necessarily represented in this answer. So I know that this mechanism is what has to happen, just because, read the textbook, take notes, whatever. And I know that my double bond has to be present on one of these substituents. In turn, that this alkene will be created by the same starting point. It's very scary. Lots of deductive reasoning, as you can tell. So if I put my bromine on something like, I know that this has to be my starting point, basically, because this is my end product. So my starting product will have a bromine somewhere. And then eventually I'm going to have an alkene. So I have to have a double bond somewhere here, and I have to have a bromine somewhere here. But I'll also have my bromine in 2 options. So if I put my bromine here, what would happen? Well, try the mechanism. If I put my bromine here, in order to have an E2 reaction, I know this is E2 because I have a strong base. This is a bulky base, by the way. In order to have E2 occur, I have to have anti-hydrogens to my bromine. So I will only be able to take hydrogens from this place because there's no hydrogens over here I can take. I can't take the hydrogen that's present, so that means I have to take from here. However, I can't because this carbon already has 4 substituents. So that also means that I can't have my bromine here because it's the same. So I can't put it there. What if I put it here? What would happen? Well, I have to steal from my hydrogen. So I could take from this carbon because it has a hydrogen here. And if I do, my double bond will form here because this H bond folds over as my bromine leaves, and my bulky base will come in and take my hydrogen. So my double bond would be here. Okay, concept check. And if I put my bromine here, this is the concept check, the same thing would happen, because if I put my double bond in this area right here, it's the exact same thing as putting it here, because you just turn it this way and then you get the same thing. So I can't put my bromine here. What if I put my bromine here or here? You would get the same thing, because if you pancake flip the molecule like this, then you would get this. So I can't put my bromine here or here. I've already basically put it here or here. So my only other option is to put it on this carbon or this carbon. since I've already done some work on this side, I'll do it on this side. So if I put my bromine here, I have to have my hydrogens that are one bond away that can be anti to my bromine. So it can either be from this carbon or this carbon, since we already know I can't take from here, there's no hydrogens to take. If I took my double bond and formed it here, then I would get this, which is, as you know, the same as this molecule. So in order to figure out these two products, I kind of did process of elimination, where I looked at, okay, where can I form double bonds, period. 2, if I form these double bonds, 1, does it make sense? And 2, will it create the same double bond as my other molecule, knowing that my 2 starting molecules will make the same alkene. So if I write out all of these things, that means that my A and B, it doesn't matter which one's which because it makes the same alkene. If I put my bromine here and I make another thing and I put my bromine here, I will create the same alkene as we've already discovered here. So now I need to make sure that my mechanism checks out. I'm supposed to get this product. So before you quit and you pick the answer that you think it is, you need to make sure that your mechanism works, because if it doesn't, then you just wasted all this time to pick the wrong answer. So in order for this to happen, here's my metal, so cute. My hydrogens bond to this metal, and this bond between the hydrogens is weakened since it's on the metal, just because of God. So this double bond, they're all floating around in space, and this carbon just kind of scoots over to this hydrogen, this carbon kind of scoots over to this hydrogen, and my double bond breaks because my carbons are now attached to my hydrogen. So that means from here to here, I now have hydrogens that are here and here, which checks because my hydrogens don't have to be represented, so that means that I got the right answer. And that might seem kind of daunting, but if you go through the steps yourself, then I promise it gets easier as you keep going. So now we're going to do another problem. I'm going to flip over my page. This one is very similar, so we're going to have the same kind of mental attitude towards solving the problem. And first I have to write it out. So in this one, we start with the same thing. We get 2 different alkenes. So here's one that's given. Love that. And then this is my magical structure I don't know yet. But my 2 different alkenes with the same hydrogen mechanism with my metal will create the same product. Just so exciting. I love that. So how do I start? Well, first you have to know, since I have this reactant, what elimination reaction is that? Since I have this is basically an acid, and it dissociates in solution because that's what acids do. I know that I have an E1 reaction, and if you are unsure of that, if you don't know what that means, then go back to my previous videos, but this is E1 because God. So I know that in my A, I have to have carbon something, my 10 carbons, bonded to an OH something. So I have this and then all my carbons elsewhere. But I know that it's not going to be in a chain, because if I made 10 carbons in a really long chain, which is my favorite thing to do, it's not going to form this. This is your hint. So I know that my B is going to be very similar to, call this D. My B is going to be very similar to D because it's going to this A is going to create an alkene that will still form the same product after my addition reaction. So what do? You're like, bro, Sophia, what is happening? Well, if I put my double bond elsewhere, my hydrogens in this case are gonna come over, carbons are gonna, kiss, and then they're gonna make something else. So starting from D, if I complete the mechanism, what will my C product be? My hydrogens come over here, my carbons and my hydrogens kiss, it's like a double date, then I'm going to make this product. So I'm going to make 2 pentagons that are stuck together with another carbon, single bond. And I know that I have 10 carbons because the carbon number doesn't change as I keep going. So I have to form an alkene that has the same sort of mechanism in order to create this. So similar to the last problem, I want to figure out where can I put my double bond in order to create this? What makes sense? So I'm going to draw this a couple times so that we can see all of our options and it won't turn into a hot mess. Move this down a little bit, and then I'll draw my third one down here. Okay, so if I put my double bond here, I'm just going to try a bunch of different spots. What if I put it here? What if I put it here? You know. Okay, so if I put it here, that means that my OH will have to be here or here, because my OH could be on either side of these, because if I redraw this, it's very important to know what mechanism you're doing. If my OH was here, then my H plus could take, actually no, after this carbocation forms, then my water could take hydrogens from here or here, which would create my double bond here or here, because the mechanism, that's how it works. I'm not going to explain that. So using this process of elimination, if I put my OH here, will a double bond form here? No, because this is not one bond away. It's just not. How about this one? If I have my double bond here, that means my OHs were originally here. Can a double bond form here? No. No. And as you can assume, my last choice, that means that my OH was either here or here. Can my double bond form here if my OH is here or here? Yes, it can. Very exciting. You're like, bro, Sophia, how did you know that? Well, through my E1 reaction mechanism, I know that if I have my same cute little pentagons and my OH here, let's compare the two to see which one is the right answer. So through my mechanism, I know that my H plus will come over and do this thing. It's gonna do its thing. And then eventually I have my H, now this H is here. My oxygen is positively charged, it's got 1 lone pair instead of 2. This is all very old information. And eventually I get a carbocation that is here. Similarly, I can have a carbocation form here. So in order to create this double bond that's up here, to make it go in the center, which hydrogens can I take? Well, I can take hydrogens from here. There's 2 right here. There is 1 right here. And there are 2 down here. Similarly, there's 2 over here. There's 1 right here I can take. And that's it. Those are all my options. So I need to pick one of these, and one of them is the right answer, one of them is the wrong answer, because I need to be able to form my double bond in 2 different places using the same carbocation. So if I use this one and I take these H's, then I can, actually just the one H, then I can form my double bond here, or I can take this H for my double bond here, or I can take this H, love it, and form my double bond here. How about this one? If I take this H, I'll form it here, which is similar to this. I can take this H and form it here, but I can't make this double bond. That won't happen. So I know that this one is not the right answer. This one can form my double bond that I need and a second alkene. So this one is the right answer. And now, if I double check my work, I'm gonna draw the D product, the D alkene that we originally started with. This is D. And then this is what I came up with. If I put my double bond here or here, it's basically the same thing, because if you pancake flip it, it makes the same thing. So I can put my double bond here or here. I'm just going to put it here because I feel like it. Now this is my B. Thus, if I do the mechanism with my hydrogens, then here's my metal, which is so cute. And here's my metal over here with my hydrogens on it now. And if my carbons and my hydrogens kiss, like this, and like this, will I make the same product? Question mark. And as you can imagine, the answer is yes, because when this double bond goes away, I have a single bond, which is what we decided in the beginning, that we're going to have a single bond. Thus, if this goes away, then I also have a single bond that is here. So I get the same answer. And this process was very similar to the last problem, except we were working with an E1 reaction instead of an E2 reaction. So if that was all kind of shaky, then I definitely suggest going back over elimination reactions. Let me know if this video helps.